lecture, we have discussed what a sequence is. Also, we have discussed the limit of a sequence. And using the limit of a sequence, we have discussed the condition of convergence, divergence, and oscillation of a sequence. In this lecture, let's recall the method used to check whether a given sequence is convergent, divergent, or oscillatory. For a given sequence n is 1 to infinity, limit n tends to infinity an. So what we do here, for a given sequence n is 1 to infinity, from this sequence take the nth number of term. So nth number of term is an. On this nth number of term an, apply limit n tends to infinity and evaluate this limit. Okay, आपको क्या करना है, जो सीक्वेंस गिवन है वो सीक्वेंस में से आपको nth नंबर ऑफ टर्म लेना है. सो दिस nth नंबर ऑफ टर्म इज an और ये nth नंबर ऑफ टर्म है, उसके ऊपर आपको क्या अप्लाई करना है, लिमिट n टेंड्स टू इन्फिनिटी. देन सॉल्व दिस लिमिट. ओके, ये लिमिट आपको सॉल्व करना है और चेक करना है कि ये लिमिट का आंसर क्या आ रहा है. इफ वी आर गेटिंग अ फाइनाइट वैल्यू, ओके, आफ्टर सॉल्विंग दिस लिमिट, if answer is a finite value, single finite value, then what we conclude, the sequence is a convergent sequence. If after solving this limit we get answer either plus infinity or minus infinity, अगर हमारा आंसर प्लस इंफिनिटी या फिर माइनस इंफिनिटी आ रहा है, then what we conclude, the given sequence is a divergent sequence. And after solving this limit, if we get the answer limit does not exist. Okay, so limit does not exist means we get more than one finite value. After evaluating this limit, if we get more than one finite value, then we can say that limit does not exist and the sequence is oscillatory sequence. Okay, so this is the condition to check whether a given sequence is convergent, divergent, or oscillatory. Okay. Now, next, using this condition, we will solve the examples of a sequence. Example number 1. Test the convergence of the sequence in curly bracket n square plus n upon 2n square minus n. So this one is a sequence. Okay, and what we mean here, small n is vary from n is equal to 1 to infinity. Okay, and this n is nothing but natural number. Okay, and first we put n equal to 1, n equal to 2, and so on. So this one is a sequence. This is the nth term of the sequence, and we have to check whether the sequence is convergence or not. Okay, so now to check whether the given sequence is convergent or not, first we should check the terms of the sequence. Okay, so now put n equal to 1, n equal to 2 in this nth term of the sequence and find the terms of the sequence. First put n equal to 1. So what we get here, 1 square plus 1 upon 2, 1 square minus 1. Okay, in this pattern put n equal to 1, so we get this first term of the sequence. Now put n equal to 2 here. So we get 2 square plus 2 upon 2 into 2 square minus 2. So this is the second term of the sequence. Same way put n equal to 3 here. So we get 3 square plus 3 upon 2 into 3 square minus 3, and so on. Put n equal to n. So we get n square plus n upon 2n square minus n. So this is the nth number of term of the sequence, and so on. Okay, so all these are the terms included in this sequence. Now, after evaluating or after solving this one, we get first term of the sequence is 2 upon 1. After simplification of the second term, we get 1 upon 1 means 1. After simplification of this third term, we get 12 upon 15, and so on. Okay, this is the nth number of term of the sequence. So all these are the elements or numbers list in a given sequence. So this is the list of numbers in a given sequence. Now the question is that we have to check whether this sequence is convergent or not. Okay. So now to test convergence, as per the definition, we have to find limit n tends to infinity an. Okay, so this one we discussed in previous lecture. What is the an? An is nothing but nth term of the sequence. So from the sequence, we have to take nth number of term. Okay, so nth number of term is what? N square plus n upon 2n square minus n. On this, apply limit n tends to infinity. So now the question is to solve this limit. Okay, now you already studied in previous standard how to solve the limit. Now for solving this limit, first of all, here we know that as n tends to infinity, okay, in limit n tends to infinity is given. Now we know that what is the 1 upon n? So 1 upon n means 1 upon infinity, and 1 upon infinity is what? 0. Okay. So generally in limit, when n tends to infinity is given, we try to convert 1 upon n form. Okay. So when we convert 1 upon n form, the value of 1 upon n is nothing but 0, and 0 is some finite number. Okay. So that's why here n tends to infinity is given. Try to convert n in a form of 1 upon n. So how to convert in 1 upon n? This is the algebraic equation. Okay. So in numerator, maximum power of n is n square. Okay, so numerator is divided by n square. Same in denominator, the maximum power of n is n square. Okay, so denominator is also divided by n square. So what to do? Dividing numerator and denominator by n square, what we get? Now here, this one, this term divide by n square. So what we get? N square divided by n square plus second term n divided by n square. In denominator, again what we have? 2n square divided by n square minus n divided by n square. Okay, so numerator and denominator divide by n square. Now here n square is cancelled, so we get what? 1 value. Okay, plus here 1n is cancelled out, here n and upon n square. So what we get? 1 upon n. Okay, so answer is 1 upon n. Same way in denominator, n square is cancelled out. So answer is 2 minus n upon n square. So 1n is cancelled out. So what we get? 1 upon n. Okay. So after dividing by n square, we get this form. Now put the limit. Okay. So put the limit. So what we get? 1 is a finite value. So 1 is as it is, plus limit n tends to infinity 1 upon n. So what is the 1 upon n? As n tends to infinity, 1 upon n tends to 0. So this term becomes 0. So what we get in numerator? 1 plus 0. In denominator, 2 is a finite term. So remain as it is. 2 minus limit n tends to infinity 1 upon n. So again 1 upon n becomes 0. So in denominator we get 2 minus 0. So what is the answer? 1 upon 2. Okay. So after evaluating this limit, we get the answer 1 upon 2. And what is the 1 upon 2? 1 upon 2 is a finite value. And again, this one is a single value. Okay. So limit n tends to infinity an is equal to finite value. What we conclude? The sequence is convergent and converges to which number? And the sequence is converges to 1 by 2. Okay. So given sequence is a convergent sequence and this sequence converges to finite value 1 by 2. Now what is the meaning of this converges to 1 by 2? Means here observe the pattern. The first value is 2, second is 1, third is 12 upon 15, means approximate we get 0.8. Okay. So first number is what? 2, second number is 1, then we get 0.8. and so on. Okay, so as we move on infinity, okay, so this pattern approaches to which number? This pattern approaches to number 1 by 2. Okay, so if we move on infinite term, or if we take infinite term of this sequence and observe the value of this sequence. So this sequence approaches to the value 1 by 2. Okay, so this sequence approaches to some finite value, means we conclude that the sequence is convergent sequence. मतलब कि हम ये सीक्वेंस में जैसे इनफाइनाइट नंबर ऑफ टर्म ले रहे हैं. ओके, फर्स्ट टर्म इज 2, सेकंड टर्म इज 1, थर्ड टर्म इज 0.8 एंड सो ऑन. ओके, तो जैसे हम ये इनफाइनाइट टर्म तक मूव होते जा रहे हैं तो क्या होगा कि ये जो नंबर है, ये जो सीक्वेंस है, वो कौन से नंबर के नजदीक जाएगी? 1 by 2. ओके, और ये फाइनाइट नंबर के को अप्रोच कर रही है, तो उसका मतलब क्या है कि ये सीक्वेंस क्या है? कन्वर्जेंट सीक्वेंस है. कन्वर्जेंट मीन्स टेंड्स टू अप्रोच. ओके, तो ये कौन से नंबर को अप्रोच कर रही है? फाइनाइट नंबर 1 by 2. सो व्हाट वी कंक्लूड? द गिवन सीक्वेंस इज कन्वर्जेंट सीक्वेंस एंड दिस सीक्वेंस converges to the value 1 by 2.